Hey, welcome back everybody. Today we are going to take a look at one of these bad boys right here. The nRF24L01 radio module. And today is just going to be a simple getting started, getting to know it, and how to wire it up, and running a simple little sketch. But before we get into that, a slight correction from my video yesterday where I was talking about the new tools for the workshop I got for Valentine's Day. When I had plugged in the power to power the Nano, I hooked up the 5 volt and the ground on the same rail. That was a mistake. 5 volt, of course, goes on the side that says 5 volt. And here, let me bring this up close. So 5 volt on the side that says 5 volt, and ground on the side that says ground. And thanks to the viewer who pointed that out for me. Sometimes I miss things here and there when I'm doing these videos. Also, another viewer, Scrubman, asked me to post some links as to where I got these things. Well, Scrubman, they will be in the comments of this video today, and I want to thank all of you guys for just taking the time out to view my videos and to be interested enough that you would actually comment on them. It means a lot to me. All right, let's take a look at this little radio module and the pinouts and all the eccentricities of it. Okay, here are some graphics that I've created to kind of explain what's going on here. And please pardon me because I am no graphic artist. These are all a top-down view of the same board. So let's start over here with how the pins are numbered. So if you're looking at the board with the antenna to the left and looking down from the top, you see you have these 2 rows of header pins here. And sadly, this makes them not breadboard compatible. So you're going to need to use some Dupont cables or whip up an adapter to make that work. Okay? But starting in the bottom left, they are numbered pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, and pin 8. Now, if you're interested, here's a little information about these modules. They operate at 2.4 gigahertz. They have a range of 329 feet. Of course, your mileage may vary. Now, very important, they are 3.3 volt only. If you put 5 volts into this, you'll be buying some new ones. However, the input pins are 5 volt tolerant, so you're good to go there. The transmitting current is 11.3 milliamps, and the receiving current is 13.5 milliamps. Now, these communicate via SPI, the serial peripheral interface. And as we looked over here at our pin numbers, here is the pin out for the SPI. Again, we have ground, VCC. Then pin 3 is CE, pin 4 is CSN, pin 5 is serial clock, pin 6 is MOSI, pin 7 is MISO, and 8 is the IRQ. Now, the IRQ is generally only used to wake up your Arduino if it's in a low power mode. Now, the library that we're going to use for this is the RF24 library. And here is the pinout that you're going to use to hook it up for this library. Pin 1 ground, pin 2 VCC, 3 is pin 9, 4 is pin 10, 5 is 13, 6 is 11, 12 is 7, and 8 is 2. So these are the pins that you're going to plug into on your Arduino. In our example, I'm using a Nano, but it works with an Uno because they're pretty much pin for pin the same chip. All right, if that wasn't confusing enough, now we'll get on to the code and how to install the library. All right, let's start with installing the library. So you're going to open up your IDE, go to Sketch, Include Library, and Manage Libraries. And it's going to pop up your library manager window. Do a little bit of update down here. And when that's completed, You know, it never takes this long when I'm not doing a video. Okay. When that's completed, come up here to the search bar and just type in RF24. And then you're going to find this here, the RF24 library by TMRH20. Now mine's already installed. If yours isn't, you're going to want to click More Info and Install. And that'll take care of everything for you. Pretty simple, right? All right, let's hit the sketch here. Now I am using this Getting Started example sketch verbatim because, like I said, this video today is just to get you guys started using this. We'll get into it more deeply in the future. So, 2 includes the SPI library and the RF24 library. Next, we're going to set a Boolean variable called radio number. Now, you're going to set this as 0 or 1. 1 is your TX radio, your transmit radio, and 0 is your RX or your receive radio. So make sure you set them differently for each of your Arduinos. Otherwise, it's not going to work. Now, hardware configuration, you're going to set it up like I showed you in the drawing there. And this is the radio or the library setup called RF24 radio. And 910, it wants to know the chip enable and the CSN pin. Then we're going to set up an array called address, 1 node, 2 node, and we're going to set another Boolean variable called roll to 0. Now in our setup we have a serial begin, and we're setting the serial port kind of fast here, 115/200. We have a serial print telling you what's going on, and then here is where we actually activate the radio. So radio.begin. Don't forget the semicolon. And then here we're just setting the power level to low. It's by default set as high. Now this is a neat little function done here, or a if statement. And it just decides which radio you're using at the time and sets it as the transmit or the receive appropriately. So we're saying if radio number equals 1, then we do radio.open writing pipe, so that's our transmit. And if radio number is 0, then we're going to open our reading pipe, and that is our receive. All right. Then here's where we begin. If this is the receiving radio, we do a start listening. Now, if it is the transmitting radio, we stop listening so that we can transmit. We do a serial print, now sending, and we declare an unsigned long variable called start time and set it to micros. Micros just gives us a convenient number that, counts up. That's all. So if radio does not equal write and start time is the size of unsigned long, then we serial print failed, which means it didn't work. And then we go back to listening. Now we say, while radio is not available, if nothing has been received, wait up to 200 milliseconds and exit the loop. Down here we have if that timeout occurs, then we print failed response timeout. Else, we're going to grab the response, which is set as a variable unsigned long got time, and we're going to do a radio read for the variable got time, and the size of it is the size of that unsigned long variable. Unsigned long equals end time equals micros. And then it all gets printed out. Wait a second, and it goes again. Now, if this is the receiving radio, there's our unsigned long variable called got time. We say if radio is available, we continue here, While radio is available, we read got time and size of, which is the unsigned long. Then we stop listening. We write back the response, and then we start listening again so that we're always listening. And we print sent response, and then we print the time. And down here is some other stuff that you can get into if you want, and it just changes the roles back and forth. But we're not going to get into that right now. Okay? Now let's take a look at how it works. All right, here we've got our two nanos on breadboards. We have our two radio modules. I'm going to power up the receiving radio. And then I'm going to power up the transmitting radio. And let's go over to the computer and take a look and see if she works. All right, here we are. So all that we need to do to start transmitting is send it a T. Bang. And you can see it is now sending. It sent this number and it got the response. And there it has a round trip delay. Now every once in a while we're getting a failed. And I believe that we could fix that by simply adding, where's that, right here, in between these two lines right here, add a delay, and I think things would work out a little better. But we'll get into that, I said, as we get deeper into these radios. This was just the getting started. So if you like this, I hope you did, please give me a thumbs up, comment, share it. If you haven't subscribed yet, what the heck are you waiting for? I'll see you guys next time. Thanks, everybody.